Hello, 30-1s. Here we are in our first lesson of our new unit called Function Operations. Well, let's talk about what this is first. We know what a function is. A function could be anything that we've been working with essentially in high school, right? We've been working with x squared and sine x and exponentials. So we're going to look at these functions again. Operation. Well, operation means we're going to do something with them. What we're going to do is we're going to learn how to add, subtract, multiply, and divide these functions. That's it, friends. So there's what we're going to do in this unit. We are going to combine functions together by adding, subtracting, multiplying, and dividing. All we got to do is learn how that works. So, as I was saying, we're going to create new functions by performing operations with these. And we'll use all of the functions that we've learned how to work with this year. What we'll begin with to start is adding and subtracting. Now, adding and subtracting these things, we're going to have two different functions, three at most, okay? Never more than three functions in 30-1. And we're going to add and subtract these things together. Now, this is generally, I think, the easiest way to write these, but I need you to know that there is a slightly different way to write them. And it looks like this. We just essentially move the parentheses to a slightly different spot. So these are equivalent statements. I prefer what's written in pretty purple myself, but they're both not too bad. All right, let's see how this works. Make sure you've got your graphing calculator with you. So here are two functions. Here's function f. It's our quadratic. It's in blue there. And here's function g. It's in red. It's our linear. And you notice I've given you the actual equations of these functions. Okay, here's what I want you to do right now. I want you to, first off, use the graphs on what I've given you. And I want you to complete the table of values below. So hit pause and complete that table of values. You can use your graphing calculator if you need to as well. All right, so there's the values you should have got by just reading off the given graph. Take a second to verify your points. Now here's what we're going to do. We are going to determine the new function and sketch it on the grid above. Okay, well, what's our new function? Let's put it in pretty green here. Well, it says h at x, we're going to add these things together. So it says we're going to add f at x, our blue graph, plus our red graph. And our red graph is this. So we're going to add these together. Okay, well, look at that. We just get ourselves a new parabola, don't we? Our new parabola is going to look something like this. I'm just going to write it sideways here. Our new parabola is going to be this. Okay, what I want you to do, pick up your graphing calculator, graph it. I want you to look at the graph and sketch it on the grid above. All right, so what I've done here is I've graphed each of my three functions. So there's f at x, g at x, and our new function h at x that we got by adding these together. I can draw them in my calculator. There it is. Okay, but let's go and let's find these points that are on this graph. So let's go to our table feature. Okay, so I'm in my table feature. If you're on a TI, it looks a little bit different, but that's okay. So I'm going to go ahead, I'm going to plot these points here. So -2, 4 was this point right here. And then -2, 7 was the point on the red graph. So where is it on h at x? Well, it tells me it's up here at 11. And I'm just going to keep going. The next point's at -1, 7. It's right there. The next point's at 0, 5. Right there. And I just keep going through this table. And what I'm hoping you're starting to recognize, next one's at 1, 5. The one after that's going to be at 2, 7. just, oh, not 2.6, 2.7, like that. I'm hoping you're starting to recognize a bit of a pattern here. Okay, here's our parabola. Okay, so we definitely know how to graph this using our calculator. But what if we don't have a calculator, or what if we don't have the given functions? Well, let's notice what just happened here. Our new function, h at x, came from these points. We just graphed them. 11, 7, 5, 5, 7. Well, let's compare our two tables. What do we notice? Well, what I notice is 4 plus 7 is 11. 1 plus 6 is 7. 0 plus 5 is 5. 1 plus 4 is 5. 4 plus 3 is 7. Oh, and look at my x values. Did my x values change? -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. Did my x values change? So, do we notice a way that we could have determined the y values without creating a new equation? Yes. All we had to do was add the y values of f at x and g at x together. That's it. I want to make a big note here. We did not change or add the x values. We only added the y values. There it is. Easy. Now, what's our new domain and our new range? Well, our domain of this guy would be, it's a parabola, so it's going to be x as an element of the reals. Okay, now I need you to be able to figure that thing out just by thinking of the functions f and g. Well, the domain of both f and g are the reals, so that's not a problem. I can think of that and come up with the answer. The range, my friends, I only expect you to get graphically. So the range, I always need you to be able to find it graphically. So going back and looking at our parabola we had, what I'm going to do is I need to find this minimum right here. So how I'm going to do that? I'm going to use my graphing calculator. So let's graph this. There it is. Let's find that minimum. And again, on a TI, second calc minimum, on the Casio, we just hit our min button. There it is. It looks like our minimum is at 4.75. So this point here, our absolute minimum, is that. So now we can say what our range is. Our range of this graph is y such that y is greater than or equal to 4.75. Y is an element of the reals. Okay, let's walk through this one more time. All we need to do to find our new function and graph it is we can add the two functions together. And when we do that, what we're doing is we're adding the y values together. We are not adding our x values. Think of it as independent and dependent variables. We can't add or change our independent variables, only our dependent variables. Okay, let's try another one. So here's a couple of graphs. Now notice on this one, f at x and g at x, I don't give you the functions. So now I can't use my graphing calculator. Well, let's try a couple of these together. So the first one says f minus g. Again, here's the other way to write that. And all this says is I'm going to go to my graphs, and it says when x is 2, that value is 3. And on the g function, when x is 2, that value is -1. And so when we subtract these, we get 4. If I had to draw that, friends, this is going to be up here, right there. So notice the x value didn't change. So when we're adding and subtracting, we're finding new y values. What I want you to do is hit pause. I want you to try B, C, and D. And when we come back, we will do E together. Okay, let's see how you did. This next one here says we're going to add f at 0 plus g at 0 together. So I go to my graph, I find the y values when x is 0, and I add them together. That's going to be 1 plus minus 1, which is 0. The next one says when f is negative 2, that's at negative 1. When g is at negative 2, that's at negative 3, and we get negative 4. And f at 1 is 2 minus g at 1, which is 0, which is still 2. Okay, again, if I wanted to plot these points, what am I getting? So again, we're not changing the x value. So if I wanted to plot b, that point is going to be at 0, 0. C, negative 2, negative 4. D, 1, 2. It's going to look something like that. Okay, what I want to do now for E is it says state the domain of this. Well, the domain, all I'm going to do is look at each function individually. The domain of this one is the real numbers. The range of g at x is, the domain of g at x is also the real numbers. So if I add these functions together, they're both going to be able to be added everywhere. So the domain of our new function will be the combination of these, which is the real numbers. There it is. Okay, so now we don't have a function, like I don't give you the equation. You don't need it. All right, let's try another one. Let's make sure you got this. So here's functions f, here's function g. I want you to pause the video and try to answer all 4 of these questions. Okay, take a moment. Check to see if your values match what I came up with. Again, we're not adding or subtracting the x values. We're adding and subtracting the y values. The x values are not changing. Now, the last question, D, is probably the most important one for what we've been seeing on our diploma recently. State the domain of f and g. Well, as I just said, we're only adding and subtracting the y values. So I'm going to start over here on the left at negative 3. I can add or subtract these x values. Or when x is negative 3, I can add or subtract the y values, I should say. I can add or subtract the y values here, and here, and here, and here, and here, and here. Essentially, I can add and subtract the y values wherever they both have a common x value. But look over here. To the right of 4, I can no longer add and subtract these functions because there's nothing on function f for me to add with, is there? So the domain of these two functions combined is essentially where they both overlap, where they both exist at the same time. So our domain, starting at the left, well, they both exist at negative 3, including negative 3, and they both stop existing when we combine them together at x is 4. Again, because there's nothing to the right of 4, there's no numbers larger in our domain for f at x of 4, so we can't add something that's not there. So our domain is where the domains coexist. That's it. Okay, I like to think of that as where do the graphs overlap. That's all I need to think about. So again, domain, I need you to be able to get for me by comparing the functions, either using the equations or using the graph. Range, I expect you to get by graphing. All right, last question for the day. Tells me the domain of f at x is this. It tells me the domain of g at x is this. And it says we need to find the domain of our new function, and we're subtracting these two things. Well, I like to, on questions like this, where they're just giving me domains, I like to draw a pretty picture. And I'm not very good at drawing. So I'm going to draw a pretty picture. That's as good as my pretty picture gets. There's f of x. And I'm going to say, here's x is -3. Here's x is 6. Okay, there's my pretty picture. It's a straight line. I'm going to draw g at x. Well, g at x doesn't include -3, and it goes a little bit further over here to 8. Okay, so what's my domain then of h at x? My domain is where these two functions coexist or where they overlap. Well, they don't overlap at -3 because g at x doesn't include -3. So it won't include -3. Where do they stop overlapping? Well, they're going to stop overlapping at 6. So what's my domain of h at x? My domain of h at x will be that, where they both exist. Draw a picture, right? It's not a pretty picture, but it sure satisfies the conditions. Okay, friends, at the end of this in the gray box, what's really, really important when performing operations on functions like adding and subtracting, the only value that will change is the y value. Do not touch the x. There it is, adding and subtracting. Guess what? Multiplying and dividing, going to be almost the exact same. Hope that helped.